Is it recording?
Yeah.
Okay. Yeah, so I'll just copy and paste that right onto the test, so you'll get that same list of formula. I didn't make up the test yet, but basically this is always what it looks like, and it's really only an hour long. Okay. So,
Are we going to start the next unit?
I don't know.
Okay.
I don't know.
I'll burn a snack.
Yeah, bring a snack just in case. Probably I have to make sure we're done all the material in time. But I'll look at what's left and see how many classes are left and see if we can go without it. But I'm thinking we probably have to, just material-wise, to get through everything. Okay, so question number 1. How much must you put aside at the end of each half year if in 6 years you want to have $12,000 at the current interest rate of 6.2? Okay, so 0.062 compounded semi-annually. So how many times is that a year? Twice. And 6 years, so time is 6. And you want, okay. So one thing you have to be really careful of, there's 2 kinds of questions. You can be saving money and it's like a one lump sum, you put the money in once and you don't add to it. Or it's happening more than once, okay, because those are 2 different formulas. So which one is this? This says how much must you put aside at the end of each half year. So you're doing it more than once. So that's one of these 2 formulas. So which one? S for saving. And so we're saying how much must you put aside, so that's, you're looking for the R, how much you're going to deposit every half year. And you want to save 12,000. So that's called a sinking fund. Actually, this is the exact example. You need $12,000. How much do you have to put in the account to do that? Okay, so we know that we want to save 12,000. I is R divided by M. And N is M times T. I give you a mark for writing the right formula down. There. Okay, so then you just plug it all in. And remember, when you're solving for R, it's easiest just to put that in a memory in your calculator and then hit divide. So I'm going to store that. Okay, so let's add to it how much interest. Okay, let's add that to it. So let's add how much interest would be earned. So if you're trying to figure that out, you need to know how much you pay and then how much you ended up with your savings. So you should have paid less than, not more. If it's a loan, you've paid more. But if you've used the wrong formula, then it would work out backwards. So how much did this person deposit? 840. How many times? 12 times, right? That's the N. 840.75 times 12. Okay, so, and then the 12,000 was in the account. Right, and if you think about, I see sometimes people work it out and say they got this number wrong. You might have even written the right formula but typed it in wrong, okay? If this, when you multiply it by 12, however many times, it should be less than what you've saved. Right, that's a quick check, like you don't need to actually calculate the interest, but if you're saving money, what you deposit should be less than what you earned. If it isn't, you might have made a mistake by using the wrong formula or by plugging it in wrong. So that, just this calculation is a quick check. Okay, it's 10,000, we now have 12,000, that sort of makes sense, that would be less. And less, but not like way, way off, right? Like, if this was 120,000 and all you deposited was 10,000, you might have messed up with your decimal point or something, right?
What was the percentage? What was the rate?
Exactly, right. So if you just do that quick calculation, like take your payment, multiply by however many times you made the payment, if it's a loan, it's the opposite, right? You have deposited more than what you took the loan out for. And sometimes a lot more, yes, if the interest rate's high. Okay, so that's number one. So be careful there that you don't use the compound interest formula. This one, that's a lump sum, one-time payment, not multiple payments. So this happened every half year, so more than once. Okay, so that's that formula. Okay, number two. Says an accountant wants to withdraw $3,000 from an investment at the end of each quarter year for the next 15 years. So they want to withdraw $3,000. More than once or just once? More than once. So that's
The last one.
that's R again, right? For the next 15 years. So time is 15. How much must be deposited originally? Oh, this is a tricky question. If the investment earns 6%, compounded quarterly, assume that after 15 years the balance is 0. Quarterly is 4 times a year. So I, 0.06 divided by 4. Okay, so what formula? Yeah, so the last one, even though he's earning the interest, he's paying himself back. And anytime you're withdrawing, it's a decreasing annuity. So that is this one, the P, it decreases. So he's withdrawing money, so it's that formula. And so we're looking for the principal, the amount he must deposit to be able to withdraw $3,000. So this formula is used for paying yourself back, usually like if you retired and you're taking money out, or you won the lottery and you're withdrawing money. Mm-hmm.
In those separate life things, is it better to take the lump sum, or is it better to take the weekly allowance option?
That $1,000 a week thing?
Yeah.
Not sure, what's the lump sum?
Yeah.
Do you know?
I have to look it up, I don't know.
If I look it up, I can tell you,
Yeah.
but, I think I did figure that out last year, because the students asked me that, but,
Yeah.
if you, I forget what it was now. Is it a lump sum once?
I think so.
Yeah, and the other is not a, is that the $1,000 a day? You don't get $1,000 a day, you get a certain amount a month or
I think it's
something.
per week or something.
Yeah, it's something like that.
Because it's set for life, so it's supposed to be over a certain period of time. Anyway.
Yeah, I think it's 25 years or something. Yeah. I think it worked out to close to the same, but my advice is always take it now. You don't know what's going to happen, right? But I think that one, they have rules set up that if you die, it goes to your, like you can assign someone to take it over. And I'm pretty sure, when I'm remembering, it worked out to like $7 million or something over 20, but either way, if you saved the money yourself, like if you...
Right, put it in the account.
Right, that it worked out to about the same. Yeah. Okay, so what is this? Must be deposited. Right, so if he puts $118,000 in the bank, he can withdraw $3,000 60 times. Right, so he would be earning the interest, but it's actually just like a loan. You take out $3,000 and they add on interest. Then you take out $3,000 and you add on interest. So, 3. A woman makes $300 contributions to a savings account at the end of each month for 4 years. So that happens at the end of each month. So that's a regular payment. And the end of each month, so that's monthly for 4 years. And then makes no further payments for 6 years. Okay, so I like to do this. This is when the R happened, okay? Sort of to keep yourself organized. And then you're doing that for these 4 years, and then it sits in the bank for the other 6 years with no further deposits. I just find a timeline sometimes helps you to sort of organize what you want to do. So we can figure out this 300, but that gets us only to this point, and then that money then sits in the bank for the rest of the time. So it's a 2-formula question. So we're saving, what's the interest rate? 0.042. Okay, so we're saving, so S. Why is that so good? Is that better? Okay, so I get my answer, and I said what I usually do myself is this. So at the end, I just hit 300 times 48. That's how many payments, and it was 14,000, and I got 15,000, so it made sense. So I usually do that just to check. I didn't get a decimal wrong, I didn't plug this in wrong. That quick calculation, 300 times 48, should be your savings, so it should be less than that, because you earned the interest. Okay, now what happens to that 15,000? It's going to sit in 4, right, so N here is, it's compounded 12 times T now is going to be 6. So what's that, 72? I is still the same, and this is now our P. And we want the accumulated value. All this is doing is multiplying by the interest rate 72 times. Like when you do tax, you multiply it by the tax once. This is just doing that every time, every month. It's adding more tax on kind of thing. Okay, and I do look for a little sentence to say that you know that's the answer and where the final answer is, or circle it or something. Okay, so that I can find it.
Oh, I know the difference.
Oh. 07? Yeah, I don't know what I did. I probably just wrote it wrong, because I don't know how I could have one decimal wrong, or one number wrong. Probably just wrote it wrong. Okay. Everyone got that? So really where people go wrong on the test is not usually picking the wrong formula between the S and the P, but picking the wrong formula between these two. Whether it was happened a bunch of times or just once. Okay, so 4. If $10,000 is invested for 5 years at 8% simple interest, so simple interest is simple interest.
As soon as I see the word simple, I'm like, okay, this is the first formula, I don't even.
Exactly. So what's the 10,000? The A or the P? Yeah, it's the amount invested, so that's the original amount, that's P. 10,000, T is 5, R is 0.08, and we just plug it in. Oh, it's saying how much interest is earned, so we can do this, but you could do it a different way, do you remember? Right, just the PRT, it's just asking for the interest, not the accumulated amount. So it's actually just asking for this. So what's important with the simple interest is that time is in years. So if I say 5 months, don't plug 5 in, you put 5 divided by 12. So this portion is the interest. Okay.
So if you could do this with formula instead of like just working it in the table, would you use the S is equal to R formula?
P is for a loan.
Oh, P, okay.
Yeah. Remember to get, like, if you wanted the unpaid balance, say I didn't give you that number, then you would find that with the number of payments left, but it's always in the P formula. Like this one says the loan was, the original loan was for $100,000 for 30 years at 7.5% compounded monthly, and monthly payments of $699. I didn't need to give you the monthly payments because you could figure that out from this information, right? I also could have put 56 here but not told you this. How would you find this number?
You have to say P
Right, P of,
whatever 56.
right. So the normal loan was 30 times 12, so 360, and this is 56.
So you say 360.
So how many, yeah, minus 56. So 360 minus 56 is what, 304? Right, so you could do P of 304. I, whatever that is. But you didn't have to do that because I gave it to you, right? I also gave you the $699, which I didn't have to.
So technically you could just do that, but instead of saying 304, you could do like 305. Would it be 305 and 306, or would it be?
Yeah, you could get those from here.
Or no, it would be 303 and 30.
Oh yeah, 303, right.
Okay.
To get those numbers, but you,
Right.
yeah, if we wanted the table, then,
Okay.
so this would be 57. This is always the same. And 58. So to get the interest, you take your unpaid balance and multiply it by I. So I is 0.075 divided by 12. Is 0.00625. So to get your interest, you multiply this by, so 95042.20 times 0.00625. And that gives you these numbers, your unpaid balance. So 594.01. And then how do we find this number? It's the difference between these. So if you minus 699.22 right on your screen, you get 105. I put negatives in when we did it in class, but you don't have to.
Can you say that again? So I'm just going to write down how to find each thing, because I didn't write that.
Yeah, so the interest is your unpaid balance times your I. Yep.
And the principal you do.
Well, this is how much you paid, and that's your interest. So the difference between them, right? So this is $699.22 minus $594.01. Right, and this one would have been $699.22 minus $594.67. And then your loan goes down by that much, 105. Oops, I didn't mean to clear it. If you keep that in your calculator, you can then times by your interest. So 943 times 0.00625 And basically to mark this, if this last number's right, you probably have everything else right. I take a quick glance, but if it all works out. Okay, any questions about that one? We're good? So even though we did number 1 on the homework, let's just do that one again, because it actually asks for a number from number 1 to do number 2. So that's on the other sheet. So we'll do number 1 over again. It says Herb is saving money. He deposits a lump sum of $500 into a bank account, earning 1.2% compounded monthly. The next year he decides to deposit $50 per month. So any lump sum, he didn't do the 500 more than once. That was once. Okay, so that is separate. And then after how long? The next year. So if this is times 0, he does this once. And then after 1 year, he deposits $50 how many times? 50 per month, so more than once, into the account for the next 5 years. So like R is 50, he does that 50, 50, 50 over and over again until 5 years, or the next 5 years. And then what?
Leaves it for 4 years.
Leaves it for 4 more years. And it tells you, like, all together is 10 years. So there's no tricks with time, like, don't worry about that. It should be, there's no tricks. Like that one on that homework that you did for today said, like, on his 35th birthday, and, like, there's no tricks. It's just 20 years or 30 years, whatever it is. Don't worry about that. Okay, so here it is. Now, what I would do, there's 2 things going on. This 500 sits in the bank, and this 50 sits in the bank. So there's this 500 we deal with separate than this. You don't have a balance in the account and then start putting 50. It's calculated separately. So the 500 is like, goes forward, and then the 50 is a new one. So it's kind of like 2 accounts that way. So let's write down the interest rate is 0.012 compounded monthly. So I is 0.012 divided by 12. 0.001. And so let's deal with the 500 first. That's a lump sum. That's once. So A equals P, 1 plus I to the N. And that's for 10 years. Because we're looking for what its value is at the end of 10 years. So N is 10 times 12. It's compounded monthly, so 120. 500, 1.001 to the 120. Okay. Yeah, I'm thinking on the other homework it was a different percent, but because that number doesn't look familiar, but it doesn't really matter. Okay, so that's the first, that's the 500. Now what about the 50? So this is a regular payment. Right, so he's saving, so S. And he does that 50 for 5 years. So time is 5. So N will be 12 times 5, or 60. And I is still the same. It's the same account.
Isn't it 1.2? Or, right, I, yeah, okay. Sorry, I'm thinking of R, not I. Might you change the thing to say like $50 semi-annually or something? Would it always be the same amount, like per month, so I would be the same?
The annuities that we do in this class, the payment is always the same frequency as the compounding.
Okay.
So if it's monthly, it's monthly.
Okay.
Yeah, it's more advanced if you don't do it the same frequency. Yeah. So that in the real world, you could do that. You don't, if it's compounded monthly, for example, I'm paying my mortgage bi-weekly, every 2 weeks. But it's compounded monthly, and that's a different calculation than this. They're always the same. I think that's what you were asking, wasn't it?
Yeah.
For real? For real? That's what you were asking?
I was just curious if it would make a difference if, like, where the I is the same in this one, because it's R over whatever it is,
Yeah, so it doesn't have to be monthly, it could be anything, could be...
Right, but like in the first part where you're talking about it being, it's compounded monthly, but then he deposits 50 per month, so what if he deposited 50 per something else?
Then it would be compounded this something else.
Right, so it would change the I, right?
Yeah, but you wouldn't change in the same question.
Okay, that's what that.
Yeah, because it's still one account. He's
Okay.
putting it in the same account.
Okay, so it
Yeah.
can't change that.
Right. If you had 2 different accounts set up, you could have 2 different interest rates or 2 different compounding. You'd still do to the end, but different I's.
Right.
But it would have to be 2 different accounts for that to happen.
Okay.
Yeah. Okay, so this amount is where on our number line? That's this. It's only to here. Right? That figured out the end of doing that deposit. So what do we now need to do with that? It needs to sit in the bank like a lump sum for 4 years. Just like that 500 sat and we didn't add to it. We're not adding more to it. So this is 3090.24 is now a lump sum for 4 years. Does that make sense? So we take the amount that he had from the 500 and the amount he had from the 50, which was this, and add them together. So that's his all-together amount. How much did he earn in interest? Well, how much did he pay? He paid 500 plus 50. How many times did he do the 50? If you look up to the formula itself, like 50, he did that 60 times. What's that, 3,500?
50 and 60?
Plus 500?
Sorry.
Right, so that's how much he deposited. And that's, the total is 3805.82. So 305.82. Doesn't seem like much for putting money in for 10 years. Okay, does that make sense? So number 2 said Herb now takes his savings, his 3805,
His massive savings.
yes, and uses it for a down payment for a house. He might have thought better of not just saving that amount for 10 years. The house he wants to buy is $300,000. He wouldn't be allowed, you need a bigger deposit than that, but we'll go with it. Okay, so he wants to buy a house, and the house cost $300,000. 300,000, and before his down payment. So he's going to put his down payment on, and the rest will be his loan. Okay, so he needs to take out a loan for that amount, and let's write down the interest rate is 0.027 compounded monthly for 25 years. And we want his monthly payment. So 296,194. Remember not to round that interest rate off. You have to keep all the decimals. Okay, don't round that off, not to 4. If it's 5 decimals long, keep all 5. So we're going to store this number and then divide. Okay, so this is what, his monthly payment? Okay, so what's the next part say? If he keeps the house for 25 years, how much will he have paid for the house, including the down payment? So he's gonna pay $1,358.81, how many times?
12 times a year times
25?
5.
Yeah, so that's times 300. Plus his down payment. If he could afford $1,300 a month, he could have saved a little more, I'm sure.
That's what I was thinking. Like, get together.
Maybe he just got a job. So he will have paid that much. So you can see what the interest would be. Right? That includes his down payment, so you could just subtract that from the 300,000, right, which includes the down payment. Probably I asked for the interest. Yeah. So, you could do, you do your 4,076.43 minus your loan amount. Or your total, including the down payment, minus the total, including the down payment. They'll both be equal, right? You can do it both